To safely test the output of a 208 low-pressure sodium ballast, it is crucial to follow safety precautions. Firstly, turn off the power to the ballast before beginning any testing. Secondly, wear appropriate safety gear, including gloves and safety glasses, to protect yourself from potential hazards. With safety measures in place, you can proceed with testing the low-pressure sodium ballast output. The equipment required for this task includes a multimeter and voltmeter. These tools will enable you to accurately measure the voltage at various points in the circuit. Follow these steps to test the ballast output. 1. Measure the voltage at the ballast input terminals. This voltage should be approximately 120 volts alternating current. 2. Disconnect the lamp from the ballast to isolate the ballast output. 3. Connect the voltmeter probes to the lamp socket terminals, ensuring proper polarity. 4. Turn on the power to the ballast to energize the circuit. 5. Read the voltage displayed on the voltmeter. The expected voltage at the lamp socket of a 208 low-pressure sodium ballast should typically read approximately 100 to 120 volts alternating current. To interpret the results, consider the following scenarios. If the voltage is within the range of 100 to 120 volts alternating current, the ballast is likely functioning correctly. If the voltage is below the range, less than 100 volts alternating current, the ballast may have a fault or insufficient input voltage. If the voltage is above the range greater than 120 volts alternating current, the ballast may be overheating or damaged. Keep in mind these additional notes. The voltage may vary slightly depending on the ballast type and operating conditions. Lamp life can be reduced if the ballast output voltage is too high. If the ballast fails the voltage test, further troubleshooting is recommended, such as checking the capacitor and coil resistances. These checks can provide additional insights into the health of the ballast components. Always prioritize safety when working with electrical circuits and equipment. If you're not comfortable performing these tests, seek assistance from a qualified electrician. The low-pressure sodium ballast plays a critical role in the operation of low-pressure sodium lamps. It provides the necessary voltage and current to start and maintain the arc discharge within the lamp. Understanding how to test the ballast output is essential for diagnosing lighting problems and ensuring efficient operation of the lighting system. The voltage output of the ballast is designed to match the specific requirements of the low-pressure sodium lamp. Deviations from the expected voltage range can indicate problems with the ballast or the lamp itself. Low-pressure sodium lamps are known for their high luminous efficacy, meaning they produce a large amount of light for a relatively small amount of power. They are commonly used in street lighting, parking lots, and other outdoor applications where energy efficiency is important. Regular maintenance and testing of the lighting system, including the ballast, can help to prolong the life of the lamps and reduce energy consumption. When testing the ballast output, it is important to use a voltmeter with an appropriate voltage range and accuracy. A digital voltmeter is generally preferred for its ease of use and precise readings. Ensure that the voltmeter is properly calibrated before use to ensure accurate measurements. If the ballast is found to be faulty, it should be replaced with a new ballast that meets the specifications of the low-pressure sodium lamp. Using an incompatible ballast can damage the lamp and reduce its lifespan. Consider the ambient temperature when testing the ballast output. Extreme temperatures can affect the performance of the ballast and the lamp. Testing should be performed under normal operating conditions to obtain accurate results. If the lighting system includes multiple low-pressure sodium lamps, it is recommended to test the ballast output of each lamp individually to identify any potential problems. This proactive approach can help to prevent widespread lighting failures and maintain optimal lighting levels. The low-pressure sodium ballast is a key component of the lighting system, and its proper functioning is essential for reliable and efficient lighting. By following these testing procedures and guidelines, you can ensure that the ballast is operating within its specified parameters and that the lighting system is performing as intended. Always consult the manufacturer's documentation for specific recommendations and guidelines related to the ballast and the low-pressure sodium lamp. This documentation may provide additional information about the expected voltage range and other operating characteristics. Remember that safety is paramount when working with electrical equipment. Always disconnect the power supply before performing any maintenance or testing procedures. Wear appropriate personal protective equipment, such as gloves and safety glasses, to minimize the risk of electrical shock or other injuries. If you're not qualified to perform these tests, seek assistance from a licensed electrician. Their expertise can help to ensure that the lighting system is properly maintained and that all safety regulations are followed. Understanding the principles of low-pressure sodium lighting and the role of the ballast can empower you to effectively troubleshoot and maintain your lighting system. This knowledge can help to reduce energy consumption, prolong the life of the lamps, and ensure a safe and well-lit environment. The information provided is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or lighting professional for specific recommendations related to your lighting system. They can assess your specific needs and provide tailored solutions that meet your requirements. Performing these tests diligently ensures the long-term health of your lighting system. In addition to voltage, amperage can also play a role, though less relevant in this specific test. However, understanding the current draw can also illuminate potential issues. Be sure to document all readings for future reference. This allows you to track changes over time and identify trends that may indicate a developing problem. Regular inspections of the lighting fixtures and wiring can also help to prevent potential problems. Look for signs of damage, such as cracks, corrosion, or loose connections. Addressing these issues promptly can prevent more serious problems from developing. Keep a maintenance log of all work performed in the lighting system. This log should include the date of the work, a description of the work performed, and any parts that were replaced. This information can be helpful for tracking the performance of the system and identifying potential problems. Also, ensure that the lighting fixtures are properly grounded. Grounding provides a path for fault current to flow, which helps to protect against electrical shock. Check the grounding connections periodically to ensure that they are secure and in good condition. Finally, if you notice any unusual behavior from the lighting system, such as flickering lights, dimming lights, or buzzing sounds, investigate the problem immediately. These symptoms may indicate a problem with the ballast, the lamp, or the wiring. Ignoring these symptoms can lead to more serious problems and potential safety hazards. Replacing an older ballast with a more efficient model can save energy and reduce operating costs. Look for ballasts that are labeled as energy efficient or that meet the requirements of the Energy Star program. When replacing a ballast, be sure to properly dispose of the old ballast. Some ballasts contain hazardous materials such as mercury and must be disposed of according to local regulations. Check with your local waste management agency for information on proper disposal methods, and consider upgrading to LED lighting. LED lighting is significantly more energy efficient than low-pressure sodium lighting and has a longer lifespan. While the initial cost of LED lighting may be higher, the long-term savings in energy and maintenance costs can make it a worthwhile investment. Before making any changes to your lighting system, consult with a qualified electrician or lighting professional. They can assess your specific needs and provide recommendations that are tailored to your requirements. Furthermore, confirm that the ballast is compatible with the specific low-pressure sodium lamp being used. Different lamps may require different voltage and current characteristics. Using an incompatible ballast can damage the lamp or reduce its lifespan. Verify that all wiring connections are secure and properly insulated. Loose or damaged wiring can create a fire hazard or cause the lighting system to malfunction. Inspect the wiring periodically and repair any damaged connections immediately. And use appropriate wire connectors and terminals for all wiring connections. Avoid using wire nuts, which can loosen over time and create a potential fire hazard. Use crimp-on connectors or terminal blocks instead. Maintaining a clean lighting fixture is important for optimal light output. Dust and dirt can accumulate in the fixture and reduce the amount of light that is emitted. Clean the fixture periodically with a damp cloth. This can improve the brightness and efficiency of the lighting system. Lastly, ensure adequate ventilation around the ballast. Overheating can shorten the lifespan of the ballast. Make sure that the ballast is located in a well-ventilated area and that there are no obstructions that could prevent airflow. Proper ventilation will help to keep the ballast cool and extend its lifespan.